Today we're going to talk about 7-3, Triangle Similarity, in particular, Side Angle Side, or SAS. So we have theorem 7-3-3, which is Side Angle Side Similarity. If two sides of one triangle are proportional to two sides of another triangle, and their included angles are congruent, then we know the triangles are going to be similar. So what exactly does this mean? If we have two triangles, triangle ABC and triangle XYZ. If you are told, let's say that the length of AB over the length of XY, so what we're talking about is this left-hand side over the length of that left side there, the corresponding sides. So if this ratio of AB over XY, if this ratio is equal to, let's say, BC over YZ, so again the corresponding sides, BC, YZ. If we have this proportion right here, whatever this ratio is and whatever this ratio is, if they are equal to each other, what we know is that those side lengths are proportional. Furthermore, if we knew, well, we're talking about AB and BC, so the included angle is right here, angle B and angle Y. So if angle B is congruent to angle Y, well then that's when we can use this side angle side. So these are the different requirements you need. You need a proportion, which we talked about here, and we need two congruent angles. So let's go ahead and use this in an example. We want to verify the triangles are similar. So we have triangle DEF here and triangle KHJ. And we want to show that they're similar. Right now, to do this, we have three ways. We're either going to use angle, angle, side, 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 or this new side angle side. These two are prior knowledge. We did AA and SSS earlier. The SAS is the new stuff. So to do this though, let's see. We know a few of these are talking about the sides, so we could compare some corresponding sides. Let's look at the length of DE and put this over the length of whatever the corresponding side is in the other triangle. So if we were to take this triangle and try to lay it on top of this DEF, which sides would correspond? Well, it appears DE and HJ. So what is that? DE is a length of 2, HJ is 1, and so we trying to reduce this. The ratio is simply 2 over 1. Alright, now let's go ahead and look at another side. So we looked at one side. Let's see, a second side we have is, talk about DF. Notice I'm talking about the lengths. My top number on top here is going to be just the lengths on the left-hand triangle. Now on the bottom side will be the right-hand triangle. Again, it's the side that matches up. It's that corresponding side. So it's DF over HK, which we see as 5.8 over 2.9. Now you try to reduce this as much as possible. You can type into a calculator. What you're going to get is simply 2, or in other words, 2 over 1. Now because these two match, because they're 2 over 1, we know that the corresponding sides are proportional. Now we could look at another side. If we looked at the other side, unfortunately we don't know the side lengths, so automatically we're not going to use side, side, side. If you look inside of this triangle, angle, angle probably won't work because you don't know two angles. So now we have side, angle, side, hopefully, which will work. We talked about this side and this side. In order to use side, angle, side, you have to use the included angle. So in this case it's 70, or angle D. So angle D, this is our third criteria, angle D is the included side. Angle, hopefully this is congruent to the included angle over here. Well, let's see, that included angle is this one, right? It's an angle H. We do see that angle D is congruent to angle H, and that's just given to us there since they're both 70. And therefore, by side angle side, triangle DEF is similar to triangle HJK. And now we are finished. Continuing from our previous example, we want to now find the length of EF if the length of JK is 2.5. Well, to start things off, we must know that these are similar. Luckily, we do. We know that triangle DEF is similar to triangle HJK, and this here is from the previous. We just did this. You will have to show why they're similar if you were just given simply this question to start off with. If you were given this question first, you must know that they're similar. Luckily, we do in this case. So our triangles are similar. Therefore, what we could say is that all of these ratios will be equal. DE over, well, what matches with DE? JH is the corresponding. DE will be equal to DF, and that's corresponding to HK. And again, that will be equal to the ratio of EF over the corresponding EF looks to be JK here. From the previous, what we knew is that DE is 2, JH is 1. So all of these ratios should be 2 over 1. Now we're dealing with EF and JK. EF appears we don't know what it is. So let's leave it as EF. And JK is 2.5. Now we must solve for EF. We can only, or we could look at the entire equal ratios here, but it might be easier to just look at the two of them right here. They're right next to each other. Well, you know how to solve this. Now you're just solving a proportion. You have 2 over 1 is equal to EF over 2.5. Solve for EF. Here we just cross multiply. 2 times 2.5 is equal to 1 times EF, or in other words, EF is equal to 5. Which really makes sense if you think about it, because all the sides on this left-hand triangle are twice as big as the ones on the right-hand side. So this solving the proportion was kind of redundant if you already recognize that everything is twice as big. All right, we have another example. It's similar to the last problem, a little bit more difficult, but what we know is that these two triangles are similar. We know that triangle, the big I, ABC, is similar to FBG. So we know that they are similar, and we want to find the length of AB. We want to find this big left side. If AC is 18, let's go ahead and write that in there. AC is 18, AF is 8, and FG is 6. We want to know the entire left-hand side. So it's going to be bigger than 8, we know that, but we don't know exactly what it's going to be. Well, how do we do this? Well, we do know that these two are similar triangles. We know that ABC is similar to FBG. Because of this, we know all the sides are proportional. So we know that like this big left side is proportional to the little left side. The big right side is proportional to the little right side, etc. So what we can do is set up a proportion. Set up a proportion of the sides that we actually know. So let's say like the big bottom, AC, over the little bottom, FG, will be equal to the big, we want to talk about AB, so let's just introduce AB over here, which is the big left side. So AB over the little left side, which is FB. So far so good. Let's go ahead and substitute some values. AC is 18, FG is 6, is equal to 8AB. AB we don't know what it is, and FB we don't know what it is. So let's just say that FB is X. Do we now know, can we now substitute something in for down here? Well, yeah, we can substitute X. Now, how about AB? Can we substitute something for AB? Well, AB, this entire left side, it's going to be an 8, but it's also a little bit of x. So it's 8 plus whatever x is. 8 plus x. So on top we have 8 plus x. Now, believe it or not, we're actually good. We can solve this proportion now. How do we do it? We cross multiply. 18 times that x is equal to 8 plus x times that 6. So our left side becomes 18x. Our right side becomes 48 plus 6x. And now solve for x. Subtract the 6x over. We see that 12x is equal to 48. So we see that x is equal to 4. Now our answer is not 4. Because remember what we defined x is? We defined x as FB. So FB is 4. Therefore, what we see AB is, because that's what we're trying to find, AB is that 8 plus 4, or in other words, a length of 12. And now we are finished.